Good morning, children. Welcome to our next class. In last class, you learned about different shapes of magnets and magnetic uses, and you also learned about the discovery of magnet. This all will be completed. In today's class, we are going to see about directive property meaning and how to protect the magnets from demagnetization, and what's the meaning of a single touch and double touch methods. This all we are going to learn in today's class. Before understanding about the directive property, you see one bar magnet without any indications. North or south directions, no direction is indicated on these bar magnets. Then how to identify in a bar magnet which direction or which part of the magnet is indicating the north direction and which part of the magnet indicating the south direction. To find out, you can do one activity. Here you take a magnet and tie to this stand with a thread, and just drag the magnet and leave it. Give a movement for this magnet, disturb this magnet and leave it. Because of this thread, the magnet starts moving. After moving some time, then it stopped the movement. When it stopped the movement, the part which is showing towards the north side, then this direction is the part which is moving towards, which is showing towards north, is the north pole of this bar magnet, and the part which is seeking towards south is the south pole for this magnet. So in this way, identifying the poles of the magnet is known as directive property. And you also learned that magnet always have two poles. It indicates two poles, north and south poles. By using this only, your magnetic compass is working. Magnetic compass has a needle in the middle called as magnetic needle. It always points towards north and south directions. A magnetic needle is arranged inside a box and covered with a glass. This we are calling it as magnetic needle. So this we use to identify the directions, and this is also you learned in last class, right? So now you understood about the directive property, how a bar magnet shows the north and south directions. This property is nothing but the directive property. And how to make an iron piece into a magnetic material. This we'll see now. Take an iron piece, arrange on a table and point, you label it as A and B to the edges of this iron piece. And now take one bar magnet, touch the north side of this magnet to the iron piece, start at one end point of the iron piece. Right from the A, you drag your bar magnet from point A towards point B without lifting the bar magnet. Drag this magnet from point A to point B. This is known as single touch method. And in the same way, From point B to point A, you drag your bar magnet without lifting. And again from A to B, from B to A, drag the magnet. Rub with the magnet to the iron piece. When you do more than 2 times, it's called as double touch method. So by using a single touch or double touch method, you can make this iron piece into a magnetic piece or magnetic properties it gains. Then after doing this single touch or double touch methods, then take your iron rod or iron piece to the iron fillings. As we did in the last class, when you keep a bar magnet with little distance from the iron fillings, how all these iron fillings will come and attracted by the magnet. They'll attach to the magnet you had seen and you also did an activity. In the same way, after doing this double touch and single touch methods, then bring your iron piece to the iron fillings, near to the iron fillings, and you can see the attachment of iron fillings are getting attracted towards the iron piece where you used for single and double touch method. So by this you can understand, you can make any material into magnetic property it can get by the method of single touch or double touch methods. In the same way, you also learned every magnet have some attraction power because of the field which is created around the magnet. So it has some attraction. When you bring another magnet near to this magnet, like poles always repels. That means when you keep another magnet's north direction of the another magnet, when you bring to the north direction of this first magnet, these two magnets will not show any type of attraction. They both are getting repelled. This repulsion is occurring because of like forces will never get attracted. For example, if you bring another magnet's south pole near to the north pole of the another magnet, then these two magnets are attracted to each other. This is because the opposite poles of the magnets get attracted. This is also one of the property of magnets, like how they are showing directive property, how they are always indicating two poles like north and south poles. Same way, magnets are also like poles gets repelled and unlike poles are always attracted. And around each magnet, it shows some force of attraction. At some distance, it shows that force. Up to where it is showing the force, this area is known as magnetic field. So around this magnetic field area, when you bring any other magnet or the materials which can get attracted by the magnet are called as magnetic materials. When you bring any magnetic material into this magnetic field, they are getting attracted towards this magnet. So now you can understand why the magnets are getting attracted to each other, why sometimes they are repelling from each other. When like poles are near to each other, they repel. When unlike poles are near to each other, they are getting attracted. And sometimes Magnets will never show any type of attraction or repulsion. That is because of demagnetization of magnets. When magnets lose their properties, that's known as demagnetization of magnets. Why the demagnetization is occurring? Why magnets are losing their magnetic power, magnetic force? Because when we repeatedly use the magnets and when we not storing properly, then the magnets lose their magnetic capacity. When you are storing these magnets, suppose when you are storing 2 bar magnets in a box, like poles should be near to each other. Both the north poles should be one side so that they won't get attracted and they can be safe for many times. And while using magnets, when you drop them down for many times, that is also one of the cause for losing magnetic attraction or magnetic properties. Then that magnet becomes demagnetized. So when not storing properly, by repeated use and by mistake when it dropped down, these all are the causes for demagnetization. So you must store the magnets after the use, store them properly. Repeated use must not do and handle them carefully. And by hammering, many times by hammering also magnets lose their properties. And even by heating, overheating, hammering, these are also causes for demagnetization. So this should not happen. They should not repeat when you are storing your magnets for longer time. So now you understood about demagnetization, directive property, and magnetic field, and single and double touch methods. And last one, in which areas we are using magnets. What are the uses of magnets? In last class, we had seen that our headphones are having the magnets. Even your laptops, your computers are having a magnetic chip which helps to store the information. And this phone, microphones, and the satellites they are using, and many areas, near ATM machines to store the information, magnetic chips they are using, and some trains, automatic trains they are using, microwave machines they are using the magnets. In every field we are using magnets. So when the use of magnets is more, take care of the magnets also should understand by us, and we must utilize our materials properly. Okay children, once again we'll recapitulate what you learned in today's class. You learned about the directive property of magnets, how to identify the north and south poles in a bar magnet when it is not indicated on them. That property itself known as directive property. And how to make an iron piece into a magnet. A method called as single touch or double touch methods are helping to convert or to change an iron piece into a magnet. That you understood. And why the magnets get attracted and they repel from each other you learned. And what is the meaning of magnetic field you understood. And What are the different areas or different materials we are using, the magnets you learned. And what's the meaning of demagnetization? You understood. How to store the magnets properly? You understood very well. Now once again, read this Fun with Magnets lesson from textbook and textual exercises you try to complete in your notebook, children. The lesson backside some exercises are given. Write that answers in that worksheet. Find out the answers and write in your classwork, children. That's your homework. Thank you.